back, let us look at another application problem on solving right triangles. So guys, this time, this is the scenario. You are somebody, you can think of someone being on in a balloon, and hot balloon, and that hot balloon is 2 kilometers above the ground. So let us try to draw a visual, and then from there we should be able to figure out what is missing and what we have to figure out. So guys, let us say somebody or you are up here in this hot balloon. I will try to do my best to draw something. And from here, you are looking directly. So this is, it already gives us that information that this is 2 kilometers up in the sky from the ground. So let us say this is, I'm going to try to do a better job here of drawing a straight line. Okay, hopefully this is slightly better. Guys, this is 2 kilometers from the ground. So let us say this is my ground, okay? And the other pieces of information that is provided to me is that somebody in this hot balloon is looking directly in the same side. So that person is looking at 2 points on the ground on the same side. Sometimes, guys, the problem says it is looking east one side or west or some other directions. But here the person is looking on the same direction. So let us assume that the person is looking to the, let us say, to the east, okay? So the angle of depression at 2 points. So there's 2 points. Let's say this is point B. Let us call this A, this B, and then this as point C. So this person is directly looking down at point C, at point B first. And the angle of depression, because the person is looking down, so we are going to be first talking about the angle of depression. Guys, the angle of depression is 81.2 degrees. And keep in mind, angle of depression is always measured for the line of sight with respect to the horizontal, not the vertical. It is always with respect to the horizontal. But in this case, the horizontal is going to be this imaginary line, which is basically parallel to the ground, right? So it is this imaginary line parallel to the ground, and the angle of depression is going to be this angle right here, which is 81.2 degrees. Guys, that is the first angle of depression from the balloon, which is 2 kilometers above the ground, and looking at point B. Then the person looks at point C, and for point C, the angle of depression is 13.5. So let us try to draw that point C. Let's say this is point C, and the angle of depression for this point is 13 point. So guys, keep in mind this is not drawn accurately, so it's just a rough sketch. So if this does not look like 13.5, that's, I mean, I'm sorry about it, but it is, at least we can see that it is less than this bigger angle, okay? Now from this given piece of information, what do we have to figure out? We have to figure out how far is point B and C from each other. So let us try to kind of create this right triangle. And from this right triangle, we got to figure out the distance between B and C. And let us call this distance as X, okay? And if we call this X, let us call this as Y, but all we need to figure out is the value for this X. What is the distance between point B and point C? Guys, before we start doing it, we almost have a right triangle. So actually we have two right triangles. So let us actually kind of join this. We can join this, and you can also join this if you want. You don't have to really. So you have two right triangles, but guys, keep in mind, we know for the angle, for two parallel lines, that this angle and this angle are going to be the same. And we also know the fact that angle of elevation is equal to the angle of depression. Guys, that is something I already talked about in my first introductory video of where we talk about the angle of elevation and angle of depression. So this angle basically is same as this angle. So instead of working with this angle of depression, we should be working with this same angle, but now it will be called as the angle of elevation. So 81.2 degrees. And guys, it is easier for us to work with a right triangle like this. So that's why we want to transfer this angle to right here, okay? Similarly, this is angle of depression for the other point, and this angle is going to be exactly same as the angle of elevation if, for example, you were looking up at the balloon, okay? So it is 13.5 degrees. So now once we have this setup, guys, we have the right triangles, two right triangles, we have the angles. Guys, you can leave it like this, but if that creates a confusion, sometimes in some cases, if people get confused, you can just get rid of that extra information if you want. Guys, you don't have to get rid of that information, but if it confuses people, then you can get rid of that information and draw like two right triangles like we see right here, okay? So you just have to focus on these two right triangles. Now in these two right triangles, our goal is to solve for x, so we got to use both the right triangles to figure this out. Again, guys, there's no use of hypotenuse. We don't need to figure out this distance. So there's no need for us to use sine or cosine. Rather, what we should use is only the tangent function, because that is the function which relates the opposite with adjacent. Here, these are the reference angles, and this is the opposite, and this has the adjacent. It only has to do with the opposite and adjacent. Okay, so that's why we're only going to use the tangent function. So let us start using tangent function for both the triangles. Now, in many cases, guys, this is similar to example 1, if you have already watched my example 1, because we're still using the tangent function. So tangent of 81.2 degrees is opposite over adjacent, so opposite is 2 over y, right? And then we also have the other bigger triangle. In the bigger triangle, we can say that the tangent of 13.5 degrees is again opposite, which is still 2 kilometers, divided by the adjacent. Adjacent is x plus y, right? So guys, what we are going to do here is we're going to cross multiply as we did in my previous example. So when you cross multiply, you get y times tangent of 81.2 equals to just 2, because 2 times 1 is 2, and y times that, you just have to write it. Guys, for this equation, we can easily solve for y. So let us go ahead and solve for y. Again, yes, we don't really need to find y, but we will have to find y if we want to find x. So that's why we have to solve this equation for y. So you divide both sides by tangent of 81.2, and then we have to definitely use a calculator for that. So, but first let me write that step. You got to divide both sides by tan of 81.2, and you divide this by tan of 81.2. This crosses on the left hand side. From here, it implies y equals to 2 divided by tangent of 81.2. I already did that math on here. So I get approximately 0.30 kilometers. So the length, or this distance from A to B, is 0.30 kilometers. But we are interested in finding the distance between B and C. In order to do that, guys, we can go back here. We can cross multiply. So let us cross multiply. What do I get? I get x plus y on the left hand side, and then it has to be multiplied or distributed with tangent of 13.5, and then this equals to 2 times 1 is still 2. Now guys, I already know the value for y, so I'm going to substitute that. So this is going to look like tangent of 13.5 times x plus 0.30 or 0.3 equals to 2. Then to find x, guys, we got to distribute this. There's few other ways. You can also first divide. Let me see what I did. Oh, I first divided. But guys, there's few different ways. So you can first distribute and then isolate. But what I did was I just divided both sides by tangent of 13.5. So I divided the right hand side as well. So this crosses out. Then I'm left with x plus 0.3. Guys, if you want to distribute and all that, you can do it. That might be some extra steps, but you can also like divide both sides by tan of 13.5. You will get rid of that tan of 13.5 here. You'll be left with x plus 0.3. And this I did not even try to simplify yet using a calculator. I just wrote it out. And guys, you should not try to simplify using calculator. You should do it only at the end, the last step. So the last step is going to be subtracting 0.3 from both sides. So when we do that, this crosses, I get x by itself. So then I just use my calculator to do this. Guys, keep in mind, I put this in a parentheses, okay? Otherwise, you may get an answer which is completely different than the correct answer. So put that first ratio in parentheses and then minus 0.3, or do it in steps. Just first do the ratio. Whatever you get the answer, then minus 0.3. So it's up to you how you want to do it. Finally, when I simplified using my calculator, I got 8 kilometers as the approximate length between B and C. So guys, in many ways, this was similar to kind of example 1 that we saw in my previous video. But in this case, we had to find this horizontal distance, okay? In my example 1, we had to basically find the vertical distance. But the equations we started with were the same. Guys, this is example number 2. We are still going to look at many different examples. This was an example where we talked about, or the scenario was more like providing us information that the person is looking down. That means it has to do with the angle of depression. But guys, once we draw that initial angle of depression for both the cases, then we know angle of depression is basically same as angle of elevation. Okay, so guys, I will see you next time. Till then, take care.